Hello everyone. In today's video, we are going to discuss fractions and decimals. Our learning targets for today are I can write fractions and mixed numbers as decimals, and I can write repeating decimals as fractions or mixed numbers. Talking about fraction and decimal representations, we know that values can be represented in several ways. For example, we can write a fraction as a decimal, and we can write a decimal as a fraction. If a fraction converts into a decimal that eventually stops, we'll call that a terminating decimal. Otherwise, if a fraction converts into a decimal with a repeating block, we'll call it a repeating decimal. Now, if we want to convert fractions to decimals, I use long division. My denominator is called my divisor, and my numerator is called my dividend. My divisor goes on the outside of my long division bar, and my dividend goes on the inside. So 8 would go on the outside, 3 would go on the inside. I know 8 does not go into 3, so I would have a 0 in my ones place, and I can add a decimal point. Now I can add a 0 after the 3. Now I want to look at how many times does 8 go into 30? 8 can go into 30 3 times. 3 times 8 is 24. Now I'll subtract 30 from 24 and get a remainder of 6. Adding another 0 and bringing it down, 6 will become 60. 8 can go into 60 7 times, because 8 times 7 is 56. Again, subtracting 56 from 60 gives me 4. Bringing down another 0, I now have a remainder of 40, and 8 goes into 40 5 times. Now I don't have a remainder, so my decimal representation of 3/8 would be 0.375, which is a terminating decimal. Using the same logic for number 2 as number 1, 16 would be my divisor, and 1 would be my dividend. After carrying out that long division, I would get 0.0625, which again is a terminating decimal. Using the same logic for number 3 as we did for number 1 and 2, 6 would be my divisor and 5 would be my dividend. When I carry out that long division, I'll get 0.83 repeating. The 3 has a repeating block because I will continuously get 3 as a remainder. That 3 will continue on forever. It will never end. So the repeating block tells me that that 3 goes on forever. So I'll get 0.83 repeating, and again, that is a repeating decimal. Looking at number 4, we have 4/9. So 9 is my divisor, and 4 is my dividend. So my 9 will go outside my long division bar, my 4 will go on the inside. Notice 9 does not go into 4, so I can carry my 0 into the ones place and have my decimal point. And now I can add a 0. 9 goes into 40 4 times, which would give me 36. 40 minus 36 is 4. Notice if I bring down another 0, I'll have 40 again, which is the first division that I did. So 9 goes into 40, again, another 4 times, which would give me another 36. So 4/9 as a decimal representation is actually 0.4 repeating, which gives us a key when I have a 9 as a denominator. So if I have a 9 as a denominator in a fraction, then the decimal representation will be whatever the numerator is as a repeating bar. So 4/9 is 0.4 repeating. 1/9 would be 0.1 repeating. 2/9 would be 0.2 repeating. 3/9 would be 0.3 repeating, so on and so forth. So anytime you see a 9 in the denominator, it will be the numerator with a repeating bar as a decimal. Number 5, 13/4. 4 is my divisor. 13 is my dividend. After I carry out that division, I would get 3.25, which is a terminating decimal. Number 6 is exactly like number 4. So 7/9 would be 0.7 repeating. And that is a repeating decimal. Now, if I want to convert decimals into fractions, I will place my decimal into the numerator, and my denominator will be a base of 10 with an exponent. That exponent will be determined on how many digits I have in my decimal. So if I have two decimals, I'd have 10 squared, or 100. If I have three decimals, I'd have 10 cubed, or 1000, etc., etc. So looking at number 7, I have 0.35 as a decimal representation. I want to convert that into a fraction. So I'd place 35 into my numerator. There are two digits in 0.35, so my denominator would be 10 squared, which is 100. Now I want to simplify this fraction, so I want to take out the greatest common factor. From 35 and 100, I can take out a 5. Dividing both of these by 5, 35 by 5 would give me 7, and 100 by 5 would give me 20. So 0.35 as a fraction is 7/20. Number 8, using the same logic as number 7, I have 0.275. So I'd place 0.275 in my numerator, and then my denominator would be 1000. Simplifying that fraction, I would get 11/40. So 0.275 as a fraction is 11/40. Number 9, 8.12. Notice now I have a ones place besides my decimal. That ones place I will just leave and I won't touch. Then I will convert my 0.12 into a fraction. So I'd have 12 over 100, and I would simplify that. Simplifying 12 over 100, I'd get 3/25. So 8.12 as a fraction would be 8 and 3/25. Now, looking at repeating decimals, instead of placing a base 10 in my denominator, I will place my repeating decimals underneath a 9. So in my denominator, I'll have multiple 9s depending on how many digits I have in my original decimal. So looking at number 10, I have 0.888 repeating. Notice 0.888 repeating is just zero point 0.8 repeating. So I would have 8 in my numerator, and my denominator would be a single 9. So 0.888 repeating as a fraction is 8/9. Number 11 is just like number 10. So 0.11 repeating would be 1/9 as a fraction. Looking at number 12, I have 0.2727 repeating. Notice 0.2727 repeating is the same thing as 0.27 repeating. So I have two digits in my decimal. I'll place 27 in my numerator. And my denominator will be 2/9, or 99. Now, if I want to simplify this fraction, I want to look for the greatest common factor of 27 and 99. So I can take out a 9 from 27 and 99. 27 divided by 9 is 3, and 99 divided by 9 is 11. So 0.27 repeating as a fraction is 3/11. In this lesson, we learned when converting a fraction to a decimal, use long division. When converting a decimal to a fraction, place the decimal in your numerator and have your denominator be a power of 10 based off how many digits your decimal is. And when converting a repeating decimal to a fraction, have your denominator be a series of 9s. That's a wrap on this video. We'll see you in the next one.